So I'm going to add to the notes from our last class where we were talking about direct variation and inverse variation. So this is the last thing that we did. And the reason I want to add to that note sheet is because when we do our quiz, it'll be over this stuff. But today is going to be a different concept. We're going to be doing inequalities, and I'm going to start with linear inequalities. But I think you probably have some background in this. I mean, I know you guys have graphed lines before, of course. So a linear inequality would be something like this example. We want to graph y is greater than -3/2 x minus 1. Okay, and so we're graphing this linear inequality because there's tons and tons of x and y values that make this true. In fact, there's an infinite amount. And so instead of, writing them all out, we just express that in a graph. Well, first, this inequality sign right here, that's what makes it an inequality as opposed to an equation. An equation, that would be an equal sign. So because it's not equal to, we're gonna start off by graphing it like an equation. So I'm gonna just draw a quick XY graph, and I'll put 5 ticks in either direction. And then I'm going to graph that line. And so you remember the whole y equals mx plus b thing, okay, where our slope is -3/2, our y-intercept is -1. So I'm reviewing this because I know it's been a while since maybe you've done that. But to graph that line, I start at my y-intercept of -1. So I'll put a dot at -1. And then I have a slope of -3/2. So I'll go down 3 and over 2 and put a dot, or I could go up 3 and over 2 the other way. And if I connect those lines, that would be if it were an equation. But remember, this is not an equation, it's an inequality. So that means that I'm going to have to either shade above or below the line. But before I do that, the line, that represents the values that make the left side equal the right side. We don't want to keep those values. We just want to keep the values that get close to that line. So this is going to be a dashed line. Okay, again, it's dashed because there's no equal sign underneath here. If it was greater than or equal to, then we would have a solid line. All right, now I want to shade. I'm either going to shade the values above the line or the values below the line. And you can do this a couple of ways. I think one of the easiest ways is to pick a value either above or below the line and see if it makes the inequality true. If it does, you shade that side. If it doesn't, you shade the other side. So I'm going to pick 0, 0. Since that's not on the line, that's always a nice number to work with. And I'm going to plug in 0 for x and 0 for y. So I'm going to do 0 is greater than, well, -3/2 times 0 is 0 minus 1. So 0 is greater than 0 minus 1. That is true. And that tells me that 0, 0 must be shaded. So I need to shade that side of the line. And that is our linear inequality of that graph. All right, any questions yet? Yes. Well, when we decide, if the question is, why do we make x and y 0? We can pick any point we want on one side of the line. So I could pick any point on this top side of the line. I just chose 0, 0 because zeros are easy to work with. You could choose this point. Okay, you could use 2, 0. Any point you want, you pick and plug it into the equation. And if that one point makes this true, that means you shade that point, meaning that side of the inequality. If this came out to be a false statement, then I would be shading the other side of the line. Okay, good question. Anything else? All right, well, I'm going to ramp it up a little bit and go from a linear inequality to a quadratic inequality. All right, so we have a quadratic inequality. So now my x is not going to be to the first power, but it's going to be an x squared. So something like this, x squared plus 16x minus 16 is less than 0. And we are trying to figure out what values of x make this true. Okay, we've done problems like this in the past where this thing was an equal sign. Now the difference is it's an inequality sign, but we solve the problem in a similar way. Okay, we're just going to factor this guy. So we're going to factor that trinomial. And that's going to be x and x, and factors of 16 that could give us 16. Did I write 16? You know what? I'm sorry. I messed up my problem here. I apologize. This, I can't read my own handwriting, is going to be a 10x. Okay, sorry about that, guys. I just changed this right here so that our equation was x squared. It's not right either. X squared minus 10x plus 16. Sorry about that. And maybe you realize why I did that, because I wanted to make it something that factors nicely. So sorry, I changed that problem to do the quadratic inequality x squared minus 10x plus 16. So let's then factor this. So this is going to factor into x. I need things that'll multiply to give us positive 16 and add or subtract to give us negative 10, meaning I get x minus 8 times x minus 2. So now in this case, I'm just solving for x's. So I'm going to draw a number line. And on that number line, I'm going to put 2 and 8, which divides our number line into really three regions. We have this region to the left of 2. We have the region in between them. And then we have the region to the right of 8. And what's nice is if one number in the region works, then they all work. So what I need to do is pick a number to the left of 2, and I'm going to plug it in for x to see if it makes it a true statement. So a number to the left of 2 that would be nice to plug in. Let's try 0 again. So I'm going to plug 0 into the inequality. I don't really want to do it here. I could, but it's easier to do here because I only want to know if it's positive or negative. So again, I'm plugging 0 in for x here. So if I plug 0 minus 8, that's going to be a negative. And 0 minus 2 is going to be a negative. And so is a negative times a negative less than 0? No, it's not, because a negative times negative is positive, right? And so then this region does not work. Now let's try the middle region. A number between 2 and 8. So give me a number between 2 and 8. 4. 4 minus 8 is a negative number. Okay. And I don't even need to figure out what the number is. 4 minus 2 is a positive number. And when I do a negative times a positive, that is less than 0. And so, yes, that number does work in that region. And then we'll pick a number to the right of 8. Any number. It could be 9, could be 10, could be 1,000,000. But if I pick 10, let's say 10 minus 8 is a positive number. And 10 minus 2 is a positive number. And a positive times a positive is not less than 0. So that region does not work. So we are essentially done. We just have to write our answer because our winning region is here. So that means that it is the interval from 2 to 8, exclusive of 2 and exclusive of 8, because those were the boundary points. Those were what made the two sides equal, but we just want less than, not less than or equal to. All right, we okay so far? All right, here comes another example. So let's say we have 2x squared minus 27x is less than 7x minus 140. So we have 2x squared minus 27x is less than 7x minus 140. All right, well, what this means is why this is different than maybe this one up here is because it's not set equal to 0 or less than 0. So let's move everything to the left-hand side so they look a little bit more similar. So I'm going to rewrite this as 2x squared, and I'm subtracting 7x, so that's going to be minus 34x plus 140 is less than 0. All right, so we got to factor this guy. Well, notice these are all even. I could divide everything by 2. And if I do that, I get x squared minus 17x plus 70 is less than 0, because 0 divided by 2, of course, is 0. And let's factor this guy. So we're looking at things that I could multiply to get positive 70 and add or subtract to get negative 17. So it looks like that's going to be x minus 10 times x minus 7. Meaning our boundary points are at 10 and 7. So I will place both of those on the number line because that determines my regions where I'm going to test numbers. All right, so let me pick a number to the left of 7. So I love 0, so I'm going to plug 0 in. And again, I'm only concerned of whether or not this is positive or negative. So 0 minus 10 is a negative number, and 0 minus 7 is a negative number, and a negative times a negative is not less than 0 because it's positive. So that region does not work. A number between 7 and 10, like 8, 8 minus 10 is negative, but 8 minus 7 is positive. And a negative times a positive is less than 0, so that does work. So I'd say yes in that middle region. And then when I plug 100 in, 100 minus 10 is positive, and 100 minus 7 is positive, and therefore that region does not work. So my solution interval in this case, is from 7 to 10, exclusive of 7 and 10. All right, I got one more for you, but before I do so, are you guys okay? Any questions? Yes. Yes, good question. So I was just going to say, because you said the question was everything's been exclusive, how does it become inclusive? Well, if I made a small change to the top up here, so look up top, if I did this, if I wanted to do less than or equal to, okay, that means that my signs would be less than or equal to. So that means that I, in that case, would want to keep anything that makes the left side equal to the right side, which are my boundary points. So in that case, those would be brackets and not parentheses if it was equal to, because the 7 and the 10 make both sides equal. Okay, great question. Now, of course, they weren't equal to in the original problem, which is why they are parentheses, because the 7 and the 10 make them equal. We don't want to keep the stuff that's equal. Yes, Nicole. Another great question. Let's think about what's actually happening here. So the question was, is the answer always between the boundaries or not? Or can it be to the left and to the right? What kind of shape is that? X squared minus 10x plus 16. What kind of shape? Parabola. Which way does it open? Yeah, opens upward. What's happening here is that this is a parabola opening upward. And the way this question is worded, it's saying, when is the parabola below 0? It's below 0 right here, which is the region from 2 to 8. And the reason I explain it that way is because if I made a small change here and I said, we don't want to know when the parabola is below 0, what if we change that to be above 0? Well, then that would be this region and this region, because we would be talking about that part of the parabola. So we'll do an example just like that in a second, but just by your question, I can tell you are definitely getting that. Okay. So let's do one that's kind of like that. All right, let's say we have the inequality negative 6x squared plus 9x is less than negative 2x minus 2. And let's make it less than or equal to. Okay, added the equal to there. So we have those boundary points. All right, first thing we want to do is get everything on one side. So I'll move everything to the left. And we have negative 6x squared plus 11x plus 2 is less than or equal to 0. All right, now I could do a couple things here. I could try and factor this the way it is. Or I noticed that everything on the left-hand side, I have a negative here, and I hate trying to factor with a negative leading coefficient. So I'm going to multiply everything by -1, making that positive 6x squared minus 11x minus 2. But now notice what I am doing with that inequality sign. Remember back in the inequality days when you multiply or divide both sides by a negative, it flips the sign. So I flipped that sign to be greater than or equal to 0. And now I'm going to factor that. So this factoring is a little harder because we have a leading coefficient other than 1. But I still think we can do it. Into 6x plus 1 times x minus 2 is greater than or equal to 0. Are you still with me here, guys? Okay, so let's list our boundary points. Our boundary points are going to be 2 and -1/6. So here's my number line. I've got -1/6 and 2. And I have to test those 3 regions. Yes. So we're trying to figure out what makes this equal 0, which is 2, and what makes this equal 0. So what I did is I kind of did in my head 6x plus 1 equals 0. And then subtract the 1 over. And then divide by 6. And so you could get that by setting the factors equal to 0 to get those boundary points. Okay? Anything else? We still have to write our answer here. All right, let's test our regions. So I'm going to test something to the left of -6, and I'll pick something way to the left, like -100. And if I plug -100 in for x, -100 times 6 plus 1 will be negative, and that's going to be negative, and a negative times a negative is positive, which is greater than 0. So yes, that area makes that inequality true. I'll now pick a number between -1/6 and 2, like 0. So 0 times 6 plus 1 is positive, and 0 minus 2 is negative. That is not greater than 0. Therefore, that middle region does not work. And then I'll pick a value to the right of 2, like 100. That's going to give me a positive and a positive output, meaning yes, that region does work. So I am now ready to write my answer. So I need the left region and the right region. So it's going to be everything from -1/6. Whoops, sorry, from -infinity to -1/6. Bracket, because we want to keep our boundary points, because we want the stuff that makes them equal. And then union, bracket, from 2 to infinity. So that is our final answer. All right, any questions on that, guys?